Hi, everyone, and welcome to the third HST Hangout for the Illinois Regional Alumni Association. Tonight we are going to be talking about the incredible, interesting world of 3D printing, and we have our very own expert, Mike Story, who is going to tell you a little bit about that before we get into a conversation. So, Mike, it's all you. Is he frozen? Mike?
Yeah, sorry about that. Hi, I apologize. My name is Mike Story. I'm the managing partner of Beckett Solutions. We are a company that focuses exclusively on 3D printing services, 3D printing products, consumables, scanners, softwares, printers, and the whole works. And my partner and I started this company because we saw a tremendous opportunity in this market, additive manufacturing, and what it means for industrial manufacturing, education, medical field, geospatial, art and design, and a whole slew of other industries in which this new technology, I say new with a grain of salt there, this new technology is going to affect and has already affected going forward. So to start out with, Renee, unless you have any specific questions, Christina, I'm just going to jump in about what is 3D printing, because there's some people out there who probably don't know much about it. Tremendous opportunity in... Yes? No?
Go for it. That's what I thought we were doing, so I'm all over it.
Yeah, I just want to make sure that you don't have anything specific. So 3D printing, what is it? It's the traditional name is additive manufacturing, and it's a process by which you make a three-dimensional solid object from a digital model, typically by laying down successive layers of a particular material. That material could be plastic, and there's numerous different kinds of plastic: ABF, ABS, FDM, PLA, etc. Metals are very, very popular these days. They're very expensive, but allows you to actually print functional parts. Ceramics, gypsum, nylon, powders, paper in some cases. We represent a company that prints 3D prints in paper. And what you get with, and what you're ultimately doing, is you're taking a design that somebody created in their mind and in a digital world and making a three-dimensional object out of it. And I've got some examples that I want to show everybody just to kind of show you what this is capable of. And so you can see that this started out as nothing more than sheets of paper, and here we have a hand. We've got a nice Smucker's bottle that's been printed. I'm going to talk a little bit more about this, but this architecture model here, here's a good one. Some of you may remember Slimer from the Ghostbusters. He's printed in plastic. And then this one is kind of scary, but really cool. The Terminator, also printed in ABS plastic. And then my personal favorite, and this thing actually weighs a couple of pounds, is, some of you may remember him from Harry Potter. I apologize, the lights are really bright in here. It is name shall not be spoken, but yes, Voldemort. Stay back here, keep an eye on us as we go forward. Oh, and of course, here's our office mascot. This is Buttons. So, and what's nice, I mean, you can see that 3D printing has evolved over the last 30 years to where you actually have very nice detailed models. A lot of these that I'm showing you are just for show, for design, for architecture purposes, but we do, in the 3D printing world, we make things that are functional. This is a living hinge, so this was printed. This is just a box that closes up. So you got a living hinge there. Makes it very functional in the packaging world. I'll talk a little bit more about that. So there's tremendous opportunity. The 3D printing has really been around for over 30 years now, and the way it started was Chuck Hall, who founded the company 3D Systems, one of the two really big players in this market, wanted to figure out a way to take a hot glue gun and build up successive layers to create an object that he had a design for in his mind. And so he thought, what if I could attach this glue gun to a printer and tell it specifically where to print and how much heat to apply and how much glue to apply, and I could program it to do that. And that's how 3D printing was born. And so over 30 years, we've seen tremendous growth in the industry and changes to the technology, the speed, the capabilities, and we're talking about things that are being printed in the International Space Station now, that are going on Boeing aircraft carriers, Boeing aircraft that are going in functional machine parts, 3D printing cars, and so on and so forth. So the opportunities there are tremendous. We really see a big growth in the industry, higher demand for this particular technology, 500% some people expect in the next 5 years. But what industries would benefit from 3D printing? And again, feel free to jump in anytime. I'm just going to kind of keep going here. Manufacturing, and that's one of the things that we're going to talk about in relation to the honor study topic, manufacturing and industry, and the frontiers of what this country really was built on in the early 20th century, how we got away from it, and how we can use additive manufacturing to kind of get back to it, where that frontier leads us. Geospatial and landscape design. Where is that model? This model in particular is, it's a geospatial model, so it's an aerial scan and then a printed model. It's kind of hard to see, but we can actually make this waterproof and tile these together, and then clients can, for example, pour water down it to actually see the runoff and what the expected landscape is going to look like. So, and then taking that from there. What else is 3D printing great in? Architecture, as I mentioned. What did I do with it? We'll show this model instead. Here's half of a cathedral, as you can see, just kind of cut in half, and nice detail, nice color on here. And so this is finely detailed color that you can communicate a plan with colleagues, with customers, allow you to really showcase what you expect to produce. Design, design, art, museum. I'm sure people have heard about recent Smithsonian scanning everything in their museums as a historical record, being able to produce those for schools down the line. And 2 museums in Iraq are asking for help from 3D printing companies to scan and reproduce their ancient artifacts due to instability in the region. Medical and dental, and that's another one that we're going to kind of talk about, health and medicine as frontiers, theme 7. But I have a really cool model here of a bottom jaw, and you can kind of see the contours and the detail in here. This was also printed in paper by a company called MCore Technologies, then finished with a cyanoacrylate, which is basically super glue. And we printed this for a company in St. Louis. What they do is they build custom dental appliances on top of these 3D printed parts, and then the 3D printed parts are pitched. So what they used to have to do was scan, design, and industrial manufacture these. Now you can print these as one-off pieces and throw away, and the time to market is significantly lower. The cost is a fraction of what it used to be. How many people out there have heard of Invisalign? Since that company started, every single thing that Invisalign produces, every one of those is 3D printed on an SLS machine, which is stereolithography. What that is it's a bed of liquid resin that's cured with a UV light, and what you get is a very finely detailed piece of sorry about that. What you get is a very finely detailed piece of lost my train of thought there. Of the Invisalign braces that are custom designed. So it's literally scanned and printed for each individual person.
So
and then education.
Of their teeth? They're taking a scan of their teeth and then printing it to their teeth?
Yes, so they're taking a scan of their actual jawline, and it's literally someone's jawline or yeah, their jaw, and then that is custom printed. So it is as though it's your own jaw.
Wow.
Yeah, that's how they make Invisalign braces, and they're custom made for each patient. And then again, the cost is significantly lower, so traditional manufacturing methods. That also ties in with theme 8, exploring political economy and what that means for, how do we allocate scarce resources and what kind of policies do we do going forward. And then finally, a really big market for us is education. industrial design, architecture, engineering, medicine, fine arts, design, interior decorating. Um, this technology is very suited for the classroom because, and we're seeing this as early as grade schools, allowing students to bring their ideas and their designs to life. It's something as simple as a physics class where you can conceptualize and build a simple machine. But instead of building it with parts that you would have flying around, you actually design it in the software, and then print it. And now you have your own custom printed machine. That's physics, computer science, that kind of thing. Medicine, we're seeing in particular teaching universities are using the technology to prepare for surgeries prior. So they'll do a scan and they'll print a surgical model of a knee, a spine, a skull even, allow the students to practice on that, or in the cases of actual surgical hospitals, the surgeons will bring the models into the surgery room to prep and then reference back to during surgery, which cuts down time in the surgery room significantly, sometimes as much as 50–60%. So really, the industries in which 3D printing, additive manufacturing are beneficial are numerous, endless even. And in fact, I'm sure the more that news comes out about specialized things with 3D printing, specialized processes, the more we're going to see it become more mainstream. People are going to be looking more for it in the future.
That's like, it's just amazing. I don't know. It's like,
Yeah.
the fact that first of all that you can spew out all of that stuff, fantastic, great job.
Thank you.
Because it's incredibly mind blowing just how many ways in which 3D printing, and it's actually called additive manufacturing.
Additive manufacturing.
Term.
And so it differs from, we've had subtractive manufacturing for decades, and that is when you think of lathes and CNC machines and milling machines, basically you take a block of something, metal, wood, whatever, and you mill out your particular design. This is, you take your design and you build it up layer at a time. So that's additive manufacturing.
Okay, and like, okay, so I see it. They do it a lot with woodworking, where you see them whittling and it's spinning around.
Yes, that's a lathe machine.
That I get. So, all right, so you touched on a whole gamut of different ways that this technology impacts the honor study topic, and one of the ways that I think I found really interesting was you were saying that the communities in Iraq are looking for help with their 3D printing of their artifacts because they're losing them. I mean, they're getting damaged, that kind of thing.
We're talking about, like I said, instability in the region, and they've been casualties of attacks. Forgive me, I don't know the exact details, but essentially they want to preserve that history, that heritage, and 3D printing is a way for them to do that, even if the actual artifacts are gone.
Right. And it's cost efficient or cost effective because instead of taking those and shipping them and trying to do all of that out of the country, they get to, and I guess they get to keep it forever because it's digitized, right?
Absolutely, it's a digital file. So there's a ton of different software that you can use, 3D modeling software, CAD software. For anybody who's interested in getting into this, there's free software online, MeshLab and Google SketchUp you can download for free or just use online and start tinkering around on your own free will. And there's companies online that will 3D print your design. So you send that to them, and they, at a fee, you'll 3D print. Or what's becoming even more exciting is a lot of libraries are starting to purchase 3D printers for their patrons to be able to use. So check your local library, see if they have a 3D printer, and you'll be able to print your own design. But back to what you were talking about as it relates to the honor study topic, Renee, that is definitely a consideration for the political economy in our world. As we become more globalized, access to more information, economics and politics are going to play a role in who has access to that information and what they do with it. And one of the frontiers that we're looking at in this sphere is, we want this technology We want the ability for people to have access to be unrestricted. So people can have access to, as I mentioned, the Smithsonian is recording all of their exhibits electronically through scanning. That opens it up to now students can access that, and they can see the design, and they can print the design, and so on and so forth. Museums, educational institutions, preserving our cultural heritage is a big part of our uh, our economic development going forward. And again, who has access to that information is a consideration that we really must take into or must consider going forward in this industry and many industries.
Well, and that's the thing. I assumed, and I guess incorrectly, that this technology was still something that was incredibly expensive and incredibly limited in terms of who could actually afford to get their hands on. You're
Did
saying
Is that me or is that you, Renee? I
I don't
lost you
know,
there for a second.
it could have been me,
Okay.
but basically that I could go to my public library and potentially access 3D printing. I assumed that it was just inexpensive and incredibly limited in terms of who could get it.
And
So
that's a very, very good point, and also it relates to our theme 8, exploring political economy. Who has access to this technology? As I mentioned, it's been around for 30 years. It's been very, very expensive for 25 of those years, and recently, especially within the last 18 months to 2 years, we've seen the price, that barrier to entry for people accessing this technology come down significantly. We represent companies who make 3D printers as expensive as $60,000. They go higher than that. The metal machines, as I talked about, making functional parts, those run in the hundreds of thousands of dollars. And then as we swing back around and talk about Theme 7, I'll discuss biodigital fabrication, which is 3D printing in actual human tissue of various kinds. Those machines run into the millions of dollars plus. Yeah, they're not inexpensive. So if you go to our Facebook page, Beckett Solutions, you'll see we post stuff daily about how the technology is being used in various sectors, and education is one of those that you see that they're printing, an aorta for a 7-year-old child or a prosthesis for someone, and kind of blows your mind. But again, that kind of technology, when you're printing, I apologize, prosthesis is not digital biofabrication, but when you're printing it in biological materials, that it's expensive. On the other side of things, we represent companies that make extremely affordable 3D printing for companies, for educational institutions, for hobbyists, for consumers, everywhere from $800 up to $6,000. So now your local library can purchase a printer, and now you have access, tens of thousands of people have access to the technology. Schools, we represent MakerBot. They have their starter labs where they sell X number of printers, X amount of filament. Filament is essentially it's the material that these printers print in. It's spooled plastic, basically. That's what it is, ABS plastic or PLA or whatever it is. And now the schools can set up, and their students have access. So now you're educating the youth. And we see printers, you'll see printers on Kickstarter for as low as $200. The big difference is quality, speed, reliability. What kind of things do you not get that you get with the $60,000 printers and so on? But again, you're right. Now we're opening up access to many people who just a few years ago didn't have access. It's an exciting time to really be in this field.
well, and it opens up a lot from an educational standpoint, because I'm sure that these kids are not just, they're like, okay, I get to learn this new technology, but bringing that into so many other technologies, it really becomes a hands-on, as opposed to just a lot of theory. Being able to print out some of these things that the machines you were talking about, and doing, engineering classes, being able to use this so that they can take their designs and immediately mock them up and say, okay, well, this is how you would use it, as opposed to, talking in theory and talking about, in abstract forms. They can say, oh no, this is exactly what my design would look like. This is what it would do. And that's just got to be so incredibly exciting. for kids to learn, and for, I mean, it takes it to the next level.
Don't you wish that they had 3D printers when we were in school? I mean, I'm fortunate I get to play with one every day.
You printed Voldemort!
Yeah, I did. Oh, you guys, anybody want a banana? Because this is actually 3D printed, believe it or not. So, yeah, I get to play with these every day, which makes my job very, very exciting, very fun. But you're right. There's really two things there, Renee. Number one is where our colleges, our high schools, our grade schools are educating students, and their goal is to prepare them for when they enter the workforce. So these machines, this technology is in the workforce. You might not see it on a daily basis, but I guarantee you the manufacturing shop around the corner has got a 3D printing because they need that capability. So these students are now having access to that while they're in school. And schools want these students to be actually using the machines and learning on the machines that they'll be using when they enter the workforce. So now we're talking about, again, circling back to theme 8, cutting down on training costs, cutting down on what it takes to get somebody up to speed on the software, on the machines, mistakes, waste. Every one of these printers has waste, so if we can eliminate that. So educating our youth, and then really from just, for lack of a better term, what's cool about it for students is, yeah, you're taking your design. If I want to print, you know, if I want to print the left shark from the Super Bowl, I can do that now. I can take that and I can customize it. You know, maybe add a little something that makes it mine, and print that out. Or, more usefully, as you mentioned, for engineering students, for CAD students who are learning those skills, being able to conceptualize that and then visualize it and then actually hold a finished piece is extremely exciting. We print functional parts all the time. This, for example, is a wrench. This is the design that the 3D that they printed on the International Space Station. They sent a printer up to the International Space Station to, now instead of sending up multiple parts when they send somebody up, they send up a digital file. It's uploaded in minutes, and it's printed out in minutes or hours, and you have the solution to a problem. It kind of relates to theme 5 a little bit, Celestial Frontiers. You know, yeah, let's dig into that a little bit. So a lot of that theme has to do with what started out as space technology, or what did it take for us to get to space, and what kind of technology, and how's that improving our lives back here on Earth. And I kind of look at that theme from a different point of view. With this new technology, with additive manufacturing, what does that mean for the future of space exploration and that frontier? And what it really means is we're not limited by our earthly concerns anymore. We don't have to worry about by sending up a wrench or a nut or a bolt or a computer chip, because there's 3D printers now that will inlay electronic circuits within 3D printed materials, so you can actually print a circuit board to replace a busted one. So what does that mean? That means longer time up in space. That means more exploration opportunities as we look to future needs of our societies. Talking about colonization opportunities. Are we making our way to the moon? Are we making our way to Mars? The biggest consideration for any of those space exploration and those frontiers are, what do we do with a society on a different planet or a different celestial body that's cut off from the resources at Earth? And with 3D printers, you have the opportunity, this is years down the road, but we have the opportunity to send up printers to wherever we plan on colonizing months, years in advance, and printing out the necessary components for people when they get there. And as I mentioned, we're printing in biological materials now. I'm sure some people have seen the chocolate 3D printer, one of my favorite things to see at last year's CES. And that's well and good, and that's exciting, but what we can take is raw materials in a lightweight powdered form that doesn't take up very much space, and then 3D print consumables, edible consumables in the future. So now we're talking about completely independent societies that, as needs arise, they're able to use this additive manufacturing technology to fend for themselves, for lack of a better term. So where does that lead? What are our boundaries now of the celestial frontiers? If we're able to send a completely self-sustaining unit to a different planet, where do we go from here? And that's, again, that's a huge consideration for the future.
No, that's incredible, because all of a sudden, well, I thought I saw at one point there was a story, I think you guys shared it, about somebody making doing 3D printing bricks with mud, and they were actually building like a whole house or a whole castle, or, and I always thought, okay, they print it out and it's got to be like this big, you know, because that's how big the space can be. But they're actually printing. I mean, how big do these 3D printing objects get?
I don't know if you can see it, but there is an orange and black machine in the background there.
Yeah.
That's our 3D printer. So, and that's about the size of a refrigerator. And that's not even a $100,000 machine. So we're talking, these machines can take up, you know, several square feet, size of small offices. And again, as the technology develops, we're talking bigger, faster, less expensive. Exactly what you mentioned, Renee. And this, as we continue to explore our political economy, scarce resources, housing, what kind of future housing needs does this planet have, and where do we go from here? Raw materials are extremely expensive. The raw materials that we use to build structures, build houses, and so on and so forth. But in developing areas, in third world countries, and so on, can we use 3D printing? Can we use additive manufacturing? Can we use sustainable materials, recyclable materials to build lightweight, strong structures that are extremely ineffective, providing those resources that might not otherwise have been available? Getting back a little bit along those same lines, can we kind of explore the idea of sustainability and recycling? Can we take those waste products from those printers and then use that as a kind of recurring source of materials for those 3D printers? Or can we build lightweight honeycomb structures that are still extremely strong, that provide protection from the shelters for those going into areas of need from disaster relief perspectives? So can we provide those printers on site, or those materials on site, to set up temporary shelters, to set up temporary medical facilities, and then take those down because they're cheap, they're fast, they're fast to set up, and they're easy to move around. So again, providing those resources that we might not have the opportunity to have had prior to the invention of this technology is extremely exciting. Again, a lot of us know what additive manufacturing means from industrial and manufacturing purposes. Rapid prototyping, the ability to bring a product to market faster, the ability to design and build multiple prototypes to avoid having to pay expensive custom design jobs, or to build dies to just get one-off runs. Nike can use the technology to prototype 10 different variants of a shoe that they're looking, and they can feel it and hold it and see it and decide that this is the best one, and the other 3 get pitched, and it's 10% of what it used to cost, and it significantly saves on time. And that's all well and good. And in fact, President Obama mentioned in his State of the Union address last year that 3D printing is how the United States is going to bring manufacturing back to these shores. Because as we continue to develop the technology, we will be able to get a leg up in the market. And right now, it's a lot of injection molding, it's a lot of casting, but 3D printing is a complementary technology to those industries. So that they're bringing those industries back to shore, which is extremely exciting. So again, I don't want to be diminutive towards manufacturing and industry as this technology grows, because it's 80% of 3D printing right now is rapid prototyping. But these other fields, as I said, space exploration, the ability for relief, disaster relief, so on and so forth, I think those are as exciting, if not more exciting, for the future of this technology.
Well, and it's interesting, you were bringing up, and I had to double-check the Honor Study Topic Guide before I said anything, but Theme 4 is actually exploring the natural environment, and one of the one of the quotes in here is, as resources become scarcer and pressure for their uses increase, how will these challenges impact the frontiers of natural environments? So it's a matter of, how can we expand what we have and how can we utilize what we have differently? And I think this really feeds into that as well.
Absolutely, yeah. I kind of glossed over theme 4 when I was preparing for this, but you're absolutely right. It definitely applies to the honor study topic in that regard. Again, it's extremely exciting. We were looking into a company that takes scrap plastic, so instead of your plastic water bottle going into a landfill, they collect that from third world countries, chop it up, and create 3D filament. So now we're talking about a sustainable material to 3D print in, and it's environmentally friendly. You're getting bottles out of landfills. It's cheap. It's inexpensive. I keep saying cheap, and again, I don't mean to be saying cheap as in cheap quality, but inexpensive. Because, well, there are cheap quality stuff, but in this case, an inexpensive source of material to 3D print. So as we look and where do we go from here for the environment? What are we doing? 3D printing has a role in that, and we're talking about sustainable materials, sustainable products going forward.
That's incredible, because I never, originally when I first thought of 3D printing, I thought to myself, okay, so what's the environmental impact that this is going to have? And I assume that it's going to be negative. I assume that the materials that are used are toxic, and they're going to have to go through all of this testing and so on and so forth. But what you're telling me is I can't feel bad about this anymore.
Well, I'm not saying
feel bad about my bottle anymore.
Until we get widespread adoption, which I think is the way it's going to go. Until we get widespread adoption, you still have the environmental concerns. But yeah, the technology it plays a role in the future of our environmental concerns. Absolutely.
Good stuff. Good stuff. Now,
please.
Do you have anything? I mean, I think, is your mind blown like mine is? Like
totally. Yes. Yes.
I gotta get a break. Hold on 1 second, guys.
Okay.
I want to reach through the screen and grab his Voldemort. I don't know. I don't think technology has gotten that far yet. That's so cool. So that was one of the things that we were talking about before was the health aspect of all of this, and how 3D printing plays into that. I actually, have you seen the Robert Downey video, the Robert Downey Jr. video with Iron Man?
Yes.
I don't know if everybody's seen it. I have the video. Do you want me to play it, or do you think everybody's seen it at this point? I'll just.
It's definitely worth a play, I'd say.
Yeah.
Okay. Let me see if I can figure out the screen share thing. Here it is. Okay. So let me go ahead and share this. And you can see it now?
Yes.
Yes.
So just gonna go down here. We're looking for 912.
Hey Alex, how are you? Pleasure to meet you. I have another bionics expert on hand, so I thought I'd drop by.
Thank you.
Yeah, it's a pleasure. Nice bow tie, by the way.
Thanks.
How are your travels?
It's very good.
Well, I thought I'd bring one of my gauntlets to match it up with yours and see if everything's copacetic. You want to have a look?
Sure.
Ready?
Yep.
Great.
Each one looks the same.
Actually, I think yours might be better than mine. What do you say we both try them on, do a progress report?
Okay.
You know who that is?
Hi, Iron Man.
What's his name?
Robert.
Great. God, dude, it's even cooler than I thought. having a technical glitch. As you can see, my light isn't working half the time. You know, I design one of these, it winds up breaking on me. But what I do is I keep working on it, kind of like you're working on it with Albert.
He keeps working and working until he gets it right.
Yeah. I think yours is still a little bit more right than mine because at least, you know,
The lights work.
your light works, yeah. Ah, look at that, Dan. It's a marriage of robotic technologies. Bang, nailed it. Love it. Hey, good job, Albert.
Thank you, sir.
Yeah.
Appreciate it.
Albert has made.
Okay, so that's the gist. Oh, you know what? I don't think I expanded my screen when I showed it, did I? I'm sorry, guys.
No, you did. You
It
did.
was fine.
Okay. All right. So so that's the gist of it. But and I'm sorry if it was jumping, but I think my internet connection isn't as great as it should be. But I mean, it was fantastic. You know, you look at that and you think to yourself, now this kid has a completely new lease on life and all of these things that he's going to be able to do. And you know, how cool is it that his arm looks like Iron Man, and then Iron Man came and brought it to him.
Well, let me just say that Robert Downey Jr. is really an amazing guy. He does a lot of work for charity, and that organization that coordinated that, they are dedicated to providing better lives for children with disabilities. And Alex is a perfect example of someone who was born with a disability, but we can use technology to make his life just a little bit better. Before I get into digital biofabrication, printing and biological materials, 3D printed prosthetics are an important part of health and medicine going forward. And what 3D printing allows us to do is create custom prosthetics at a faster rate, allowing us to get out to more people and also a much better product. So I have an example here. This isn't fully finished, but this is a scan of an amputee from the calf up, and what we're doing is printing a prototype for being able to fit a prosthetic, a 3D printed prosthetic that goes underneath an actual manufactured prosthetic. And so the reason that this is important is because if this doesn't fit, we can scrap it and go right back to it and make the changes necessary, when in the past you'd have to make huge changes with the designer, with the manufacturing, with actual human beings making changes, and we can use technology to kind of speed that process up. So I'm sure you've seen online a number of stories of prosthetics. We just posted one yesterday or today about a little girl who received a 3D printed bionic arm. And this is definitely theme 7, but it also ties in with theme 8. Prosthetics are not cheap. They're not inexpensive. They are very, very expensive. So if we can use low-cost, durable materials to 3D print prosthetic devices, be those functional, static, whatever, more people will have access and will have better lives. And that also means that organizations can pop up that can start 3D printing for people in third world countries and developing nations who might not have access to traditional prosthetics. So it's extremely exciting. It's wonderful to see that going forward. What are your guys' thoughts on that?
I'm waiting for Christina. I'm trying to keep talking.
There's too many. It's like I'm just trying to absorb all of this information. It's so cool, though.
Go ahead.
No, go ahead.
I was just going to say, so with my work with the Muscular Dystrophy Association, there were many kids who had they had the braces on their legs, and just the painstaking amount of time that it took for them to go through that whole fitting process and that whole does this fit? Okay, no, it doesn't. Now we got to send it back to the factory, and in the meantime, these kids are left kind of out on their own, and they just keep thinking to themselves, well, in a couple of weeks I'll be able to walk, and just the fact that they'll be able to minimize the time that a child has to sit there and go, I only have to wait 2 more weeks to walk. That in itself is just, that's just mind-blowing to me. That, I know we keep saying the word mind-blowing, but to me that makes it real for me. You know, that's amazing. It's amazing.
Well, and I mean, that's what we see on an external basis. What we don't see is what doctors and hospitals are doing with the technology currently. As I mentioned previously, we can take a scan of a patient's whole head, strip away the flesh, the muscle, the tendons, the ligaments, all that, and we're left with a skull model. If we need to go in and do surgery on some part, we can print that, we can prep the surgery beforehand, we can cut the time that somebody's in the surgical room, reducing risk, and cut the time of recovery, and we're advancing on the medical frontier in that aspect. So, for example, I was trying to find our skull model, but I don't think it's in the office right now. So imagine Voldemort here is just a skull, and as a surgeon, you know, this is a pediatric skull, which is what Washington University down in St. Louis is doing. They're printing. They're a huge pediatric surgery center, and they do a lot of brain surgeries down there. So they'll print the skull beforehand. The surgeons will take a look at it, prepare for surgery, map it out, and then they'll sterilize and actually bring the model into the surgical room with them to be able to reference back to it as they're doing surgery. It's amazing. And spine models for back surgery, outpatient surgeries on knees and elbows and that kind of thing. We can scan and print beforehand. Doctors can show patients exactly what their anatomy looks like and what they're going to be doing to it. So hospitals are a huge frontier when it comes to 3D printing, and they're using this technology right now.
That's amazing. Like, you can see me. I'm like, I'm glad I have my glasses on because my eyes are kind of welling up. Because I've been, you know, my 18-month-year-old had to go through surgery, and it was like ear tubes, right? But just the fact that you have like a small child and they have to go into surgery, and like how crazy that is, just from a parent standpoint, that they're having routine 3-minute ear tube surgery. Just the fact that they have an ability to go in and prep themselves even better for brain surgery on a child. It's just, God bless you, because that's awesome.
And they're using inexpensive 3D printing machines to save hours in the surgery room. So that you want to talk about mind-blowing, that's it. For every additional hour somebody spends in a surgical room, the risk of infection goes up. And if we can get that down to the minimal amount of time using this technology, then it's absolutely well worth it. Now, that's all well good, and that's fun, and that's exciting, but what about digital biofabrication, printing in biological materials? And I first kind of came across this. I had a general knowledge of it, but I met someone at Honors Institute in St. Louis back in June. I can't remember her name now. I will get it before the end of this Hangout. But she's working in that field. So in the very simplest terms, it's taking biological materials and printing a tendon, a muscle, a vein, a heart valve, something along those lines. So we can take, you know, what are the considerations? What are the boundaries to taking someone's own genetic material and growing that and then printing with that going forward? You're talking about reducing the risk of rejection for organ transplants. You're talking about people not having to wait on organ transplant lists because they can print it in house. Now again, these machines are extremely expensive and they're very limited. What we're talking about is 10, 15, 20 years down the road, but we're getting there. We're getting to that place. I printed something today about I can't remember who, but somebody getting a 3D printed aortic heart valve. And while that might not seem exciting, consider someone who's perhaps Muslim. What many people don't know is most heart valve replacement surgeries, that valve actually comes from a pig. They use that because their anatomy is very similar to humans. and their genetic makeup, so there's low risk of rejection. So, but as a Muslim, that person, if they're devout enough, is not willing to have that surgery with a pig heart valve because it's against their religion. So now what can we do? We can take a little bit of genetic material and we can create our own 3D printed heart valve and put that in the person there, and we kind of remove that obstacle. So that to me is an exciting frontier. What are the limitations? What are the boundaries of 3D printing with biological material? There's also the other side of things. What are the ethical considerations? What does it mean when we've 3D printed enough of our body? Are we still that same person? Are we too artificial now? Or does it matter because it's printed in biological material? So it's kind of the same play on what I believe it was Isaac Asimov talking about. We're going to at some point have we're going to be replacing biological parts with robotic components. And as we continue to do that, at what point do we cease becoming human and start becoming robotic? Well, at what point, as we continue to 3D print necessary pieces, do we cease becoming ourselves and become something else? And I don't have the answer for that. I don't think the industry does either. There's going to be those ethical considerations, and boards convened and discussions and papers written about it going forward. But it's still exciting to see that's in our future. It's available to us very soon.
You know what's bad is that you find the philosopher quote, and you're like, okay, how much of this makes us a person? And immediately I'm like, Robin Williams had a movie about that. It's great, Bicentennial Man. And they ask the same question, and it gets to the point where it's like, well, no, he's a robot. No, he's a robot. No, he's a robot. Until he's created all of these artificial organs, and they're, you know, all of the different people, you know, in the movie are getting these organs and everything, and they go, and he basically says to him, look, I have as much artificial in me as you have in you. So what makes you a person and me a robot? You know, it's incredibly interesting for anybody who would rather go the movie route. Bicentennial Man is a good one.
I just have to say that I figured we were going to talk about, you know, the aortic heart thing and some of the stuff we've seen online. I am, like, truly speechless at all the stuff that's out there and it's being done and used, and I don't even know what to say because I had no idea that technology has come that far. You know, from the little bit I know, I thought it was paper and plastic and whatever, but this is craziness, complete craziness.
Keep in mind, a lot of what I'm talking about is future technology, and while we're on that path, and that I'm still speculating, and I'm speculating based on research and the progression of technology and so on and so forth, and most experts agree that we're headed into this realm of sci-fi-esque abilities with additive manufacturing.
Right.
But we're still years away. I mean, we are talking right now. The lower level machines are used for hobbyists for you know, printing custom cake toppers, which is cool. I mean, we go to Comic-Con, for example, and you scan people in their cosplay, and then you 3D print that and you send it to them, and now they've got a little 3D print of themselves. And there's companies popping up that will use the technology. There's a company in Bloomingdale Mall, I believe, that the company's name is 3D Figureworks. They have a series of scanning setup and a printer in-house, and you can go in and print yourself just little custom figurines. You can take your animal in there, your cat, your dog, and then 3D print that and present that as a gift. You can do ornaments. You can, for hobbyists who do like RC helicopters and planes, you can print just little heads that you can stick, and so that's you as a pilot in there. So that's, I mean, it's really cool, the stuff that we're doing now, but the stuff that's coming is what's, I hate to use the term, but mind-blowing.
Yeah.
Yeah. Well, but that's the thing, though. To me, once you're on this slope, I mean, it's just gonna gain momentum probably once everybody sees what's available and out there. And I mean, I think so many people would be like, "Sign me up. How do I get involved?" And you know.
Well, and
it's a cool.
Yeah, you're absolutely right. Sign me up. How do I get a 3D printer? How does it is it affordable yet? What do you know? Is it available on Amazon now? Where do we as consumers go? Is a really good question as it relates to theme 8 too. Um, what what's the future of 3D printing from our own personal economic standpoint? Yeah, it's all well and good with industry and manufacturing and medicine and space exploration, and that's well and good. But for the average consumer, what does 3D printing mean to them other than lower costs at the grocery store, at the hardware store, and so on and so forth? Um, and the future it means a lot because really what we're talking about when we're talking additive manufacturing is custom making something for somebody. And for consumers, what happens when we break a knob on our oven, or when the lamp base cracks or something like that? What do? We either throw it away, maybe duct tape a wrench to it or pliers so we can use it. And what we're talking about is there are some people in the industry who expect that we'll have a 3D printer in every home, just like we have a conventional 2D printer. And when that knob breaks, you'll go to the manufacturer's website and you'll download the file and you'll print it on your 3D printer. In a few minutes, you'll have a brand new knob that you put on yourself, and you don't have to worry about going out and buying that or not doing without. I talked with somebody who thought the first real foray into commercial applications would be for buttons. And okay, you think buttons, fine, whatever, but it kind of makes you think a little bit. When we lose a button and we don't have a replacement, what does that mean for that garment? Whereas if you know where you bought that and you can go and download that and then you can replace the button, it might not seem like a big deal, but if I lose a button on one of my favorite dress shirts, I'm devastated. I can't wear that shirt again. So
why do I not? Why don't I see any fault in that? Yep, absolutely, I got it.
Yeah. So if that's the first, where does it end? Where does it stop? If we have a 3D printer in all our homes, what does that mean for us as consumers? What can we print? What can we custom make for ourselves? And again, this is what additive manufacturing is. It's custom making something. It's taking somebody's creative output and making something with it. So really the possibilities as consumers are endless, and it's going to change the way that we spend our dollars in the future. Amazon, this is very, very early, but they patented putting 3D printers in the back of their, not Amazon, UPS, putting 3D printers in the back of their trucks so that they would print 3D, custom make something for somebody while they're on the road or while they're there. What we're more likely to see, in my opinion, however, is big centers that UPS has with tons of printers where they print and ship out from there. So it's going to go that commercial route. I mean, there's already service bureaus, but they really 3D printing service bureaus, but they cater more so to industry and manufacturing than they do the consumer. But the hobbyists have started to take this on. There are people who are building their own 3D printers. There are people who have a 3D printer and a part breaks on it, and then they 3D print the component that they needed to fix the printer. So it's kind of an interesting cycle.
One of the things you were talking about was just the fact that consumers are going to be able to print their own knobs, right? Mm-hmm. Well, what happens to that from an economy standpoint? What happens to all the jobs that are in that supply line? So you have the guy that used to make the knobs. You have the parts dealer that would, order you the part from the manufacturer and would get that part sent in, and then the, the fixer guy, the handyman that would come over to your house and install the knob. All of a sudden now you've lost that whole chain, and it's just a completely different way of looking at, what will jobs be in the future? Will there be somebody who's coding all of this now, that's coding all of this digital information, and that becomes the fixer, that becomes the supply line guy?
Right.
And big change in that.
It's a very, very good point, Renee. It's not all as easy as I make it out to be. It's not all roses going forward. There are we have to consider, we have to think about what does that mean for our economic frontiers from a manufacturing standpoint going forward. Does that mean lost jobs? Does that mean lower prices? Does it mean higher prices? Does it mean now we're going to pay to download that file? Do we open up new jobs, which I think we certainly are, between manufacturing the printers, servicing the printers, so on and so forth. But the person whose job was to pull the button in the knob factory or push the button, whatever, what happens to that person? We're talking, do new trade opportunities open up, new educational opportunities, and schools are almost getting ahead of themselves. They want this technology in because it's being so widely used in industry. Roosevelt University, for example, has a 3D printing class on the books for this fall. They don't have a 3D printer yet, but they have a class. So we're trying to help them decide what's the best printer for this class. What do we need to know, what do you hope to achieve, so on and so forth. That's an aside, but we're kind of getting ahead of ourselves there.
You have to throw your alma mater in there. I know. I see how it is.
Yeah, I do. I should help them out if they educated me and whatnot. But we do need to think about what you mentioned, Renee. What does that mean for the future of the widget economy, for lack of a better term?
Yeah, and then I went on your Facebook page, the Beckett Solutions Facebook page, and you guys have an incredible amount of awesome stuff. So if there's anybody who's watching this who is interested in this, you have to follow. It's not full of mumbo jumbo that you wouldn't be able to understand. It's full of awesome, mind-blowing things.
Please do like our page, yes.
And one of the things that we haven't talked about, and I know we're getting to the end. I don't want to keep anybody longer than than we promised, but quest for human expression. You start talking about art. You start talking about design, all of those things. I just shared the link for the car that you guys had posted, the 3D car. I mean, just a whole different realm of what you can design.
Yeah, that's a really good point. And again, I kind of glossed over that while reading the Honor Study Topic Guide. But that's 100% correct. That frontier, art and design, the quest for human expression, where does that fall in with 3D printing? And the answer is it's endless. A lot of what I've shown today in terms of the samples, they're artistic expressions, they're design. They don't have any functional parts. We have very few functional parts here in the office. So art and design, and Renee, I think you mentioned the 3D printed car. There was, at the International Manufacturing Trade Show in Chicago last year, at the start of the show, they set out to 3D print the components of the car, not the engine and the wheels and so on, but the body and the steering wheel and so on. And by the end of the show, they had finished the parts, they had assembled it, and they literally drove it out of the showroom, out of the show. So design takes on a whole different realm here. For example, there's a company in Cary called C Ideas. They have a car that's not street legal, so they said, what do we do with it? So let's start taking off parts, let's start refinishing it with 3D printed parts that look exactly the same, and it's kind of a neat little marketing piece for them. But it makes you think about what the future design for cars, for airplanes, for those kinds of industrial applications. And then on a very base level, on a very consumerist level, jewelry, sculptures. Jewelry is huge with 3D design, 3D modeling, 3D printing. If I'm a jeweler, if I'm a designer, I can use software to design my pieces. That's a lot easier to use than what we used to use in Photoshop and Microsoft Paint, for those of you who remember that. But now there's 3D printers specifically for printing jewelry, and you're not actually, sometimes, yeah, you're printing jewelry and it's fun, and there's an artist out of California, I wish I remember her name. Anybody would like to learn more about it, please. Renee, can you throw my email up in the chat box? That'd be fantastic. Feel free to email me about that, because she does some amazing work, and she's done earrings, and she's done sculptures, and they're the finished pieces. But more often what we're seeing is a design, and then you're 3D printing the jewelry as a mold, and that mold is used in casting. So we're mass producing, but it's a lot cheaper than injection molding these casts, because then that piece has to be taken, fitted with a slurry or an actual casting process, and then burned, melted out, whatever. There's actual 3D printers developed specifically for the intricate details of jewelry. As a sculptor, I have a new medium now. At the 3D print show in New York last February, there was a whole floor that was strictly 3D printed art. And if you go on our Facebook page, and you'll see some of these things that I mentioned, but they're 3D printing headdresses, and we're 3D printing skirts, we're 3D printing bras, or 3D printing shoes, and it's a new frontier. This is a new fashion frontier. We've got different mediums that we work with in different art worlds: clay, canvas, cosmetics, cloth, other materials, that kind of thing. 3D printing, plastics, nylons, whatever it is, that's a new frontier, and we're exploring that. The art world's exploring that. The jewelry, the sculpting world is exploring it. So, as the quest for expression, 3D printing offers another avenue in that regard.
Yeah, I'll tell you, getting a custom done 3D printed bra sounds pretty good to me. I'm all over that. I'm gonna tell you, man, that's a whole new, like, go to your house and measure you out and just print you out a bra. I love it.
Yeah, if you have custom design needs, for lack of a better term, if you have custom proportions, it's kind of exciting, but it's not really been talked about right now. But what if you have a specific design in mind for a piece of clothing, or a piece of or a sculpture, or a lamp, or something like that, and you can't find that anywhere? Well, now I can contact a designer, work with them to get the design I want, and send that out to a 3D print house to print it out for me. And now I know, if I have specific tastes, I know that no one else has that piece, that style in their house. So again, we're talking about custom making stuff for people. We're talking about taking a 2D design, something creative, something that's in your mind, getting that into software, and then actually creating that in the physical world, so that we can hold it, touch it, feel it, and we know that this is our design.
Good stuff. Oh my gosh. Okay, well, we've already gone over the amount of time, and I'm sure that we could probably talk for at least 2 more hours about how just incredibly interesting, and how this can just completely revolutionize everything. And I mean, I think we've gone through the entire understudy topic guide and found out how it can connect. So
yeah,
it's 9. So if anybody can tell us how borders and boundaries works within his, that's the only one we're missing at this point.
Well, we talked about
there's a way, but we'll save that for another time. I was just thinking about it as we're talking. But thank you very much for hosting me tonight. I have a great time talking about it. I have a great time showing it off. It's wonderful to work in the field. If anybody has any additional questions or follow-ups they'd like to discuss with me, feel free to shoot me an email with your contact info, and we'll go from there.
And use the Beckett.
Yeah, preferably use my work email. I actually, that Yahoo email address is since I was in middle school, and it's a lot more for fun stuff and personal stuff and that kind of stuff. So the work email goes right to my phone, and again, I'm happy to discuss if you have any specific research needs as you work through the honor study topic with what you're planning on doing this year. Reach out. I'm happy to help you out any way I can.
Outstanding. All right. Well, I guess we will leave with that. Thank you so much. I hope everybody enjoyed today's honor study topic hangout, and we will let you know when the next one is. Thanks so much.
Thank you.